Parting on a lathe without damaging the part. For most tradesmen, one of the most difficult and dangerous things they're going to do is parting on a lathe. In this video, I'm going to share some tips and tricks with you to help make your parting experience more successful and safer. This is going to be a fast video, so please take a moment to like and subscribe. Let's get started right now. Warning, viewer discretion is advised. This video is made for apprentices and may contain scenes that are over-explained and may not be appropriate for your skill level. Parting takes less than a minute. Let's watch it and I will break down the operations after. Show it taking the part off. Let's take a look at a little part of this video and see if the speed and feed used was appropriate. We're all going to agree that CS times 4 divided by diameter is your RPM setting for this machine. Some people turn around and they'll say, well, Ray, you're using carbide, so that's 3 to 10 times faster. Well, let's take a look at it a different way. It all depends on how much of a chip you can get off of the machine. You need to be removing a chip that's approximately 3 thou to 5 thou thick. No matter what your RPM is, that's the chip thickness that has to come off. Remember, the most important rule of machining is you have to take a chip regardless of whatever you're machining. There always needs to be a chip coming off. So in this case, you have to adjust your RPM to suit your ability to remove the chip. There are a lot of factors involved. A good place to start is 1/2 of your normal turning speed. Coolant, no coolant, or oil. What's the best? You be the judge. Let's talk coolant. Spray bottle or flood? Well, if you're using a spray bottle, people will say you never ever use a spray bottle with carbide because it causes micro cracking. Flooding, not all lathes are set up to do that. No coolant, even that small amount of coolant that we were spraying on there helps cool and lubricate the part. Oil is usually used as a last resort when you're having problems with parting, either with extreme friction, extreme heat, or the tool's too wide and you're putting too much pressure on, and it just helps the material flow off the end of the cutter better. So it all depends on the situation for what you're going to need coolant for, or if you want to go dry, or if you want to go with oil. Chip control. How do we prevent long stringy chips from wrapping around the part and getting all tangled up? In this case, it's particularly simple. All we have to do is pause the infeed just slightly and the chip will break off, and then you continue your infeed. Power feed. When should I use a power feed? Well, in this particular case, this is a one-off part. You should absolutely not use your power feed on one-off parts. If you had 100 of these to make, you could take your time and find out the best feed rate that works best for this particular part with all of the other factors involved. And yes, power feed is a good option then. But on single one-off parts, not such a good option. If I'm not power feeding, what feed should I use? You should use a constant pressure that brings a chip off of your part between 3 thou and 8 thou thick. The wider your grooving tool or parting tool, the more pressure it's going to take to produce a chip. In this case, our tool is 250 thou wide, so it does require quite a bit of pressure to produce a chip. So why is it so difficult to part on a manual machine compared to a CNC machine where it just seems to happen naturally? Well, that's because they have constant surface speed, G96. You remember how we calculated our RPM, CS times 4 divided by diameter. So the diameter part is the variable part as you are parting off because the diameter gets smaller. So on a CNC machine, as the diameter gets smaller, the spindle RPM increases. So they can maintain a certain chip thickness throughout the whole cut. So if our part was 4 inches thick, we'll say, and when we got down to 2 inches, we might want to stop, increase our RPM, and then continue on. Rigidity of setup. It's an easy thing to say, but a difficult thing to actually do. And it's different for almost every single part that you're doing. In this circumstance, there are 2 simple things that I can do. First of all, I have the part all the way back up against the jaws, and I have my tool all the way into the holder. That might seem a little silly, but leaving things sticking out a 1/4 inch or something along those lines can actually affect rigidity. Size does matter. So in this case, what's the difference between a large insert and a small insert? Well, the larger insert can take a lot heavier of a cut and is a lot physically stronger, and the base is also a lot stronger. Wow, if the larger tool is that much better, why do they even bother making smaller tools? Well, this is why. Let's go back to some basic principles. So I have 2 snow shovels here. I have a large snow shovel and a small snow shovel. The larger snow shovel will remove more snow than the smaller snow shovel will. But the larger snow shovel requires a lot more pressure to push through the snow pile. So in principle, we agree the wider the tool or the shovel, the more pressure it takes to push through the same amount of material, because our chip coming off should be a constant thickness. So the skinnier the shovel or the skinnier the tip, the easier the penetration it will be, or the less pressure it will take to push through that material and have plastic deformation of the chip occur. So therefore, whenever possible, use the smallest parting tip. There are only 3 times during the part-off operation that you don't want to maintain constant pressure. The first is when you're starting. You want to ease in and then gently ramp up to the maximum amount of pressure you're going to put. When you want to break a chip, and nearing the end, you want to back off on some of the pressure. For this example, let's say there isn't a hole already through the part, and you're parting off 100% of the actual piece. So let's take a look. There are basically 3 end profiles that we're going to use when we're parting. The first one, if we take a look at number 1, the part that falls off towards the tailstock is going to have a finish with no nub, and it will leave a little nub on the part that's still in the chuck. Part number 2 is going to do the opposite. It's going to leave a nub on the part that falls off, and it's going to finish the part that's in the chuck. And then there's option number 3, which is a neutral. Keep in mind my option 1 and 2, they're a little bit more predominant of an angle than what we would use. We'd probably use around a 1 degree angle, but you wouldn't be able to see a 1 degree angle if I drew it. Okay? You as a new apprentice should be setting up your tool perpendicular to the axis of infeed and also on center. In this case, we used a pin to catch the part. Sometimes people are going to want to use a center. You can't really use a center because what happens with a center is it actually physically pinches the workpiece against the tool and can cause all sorts of issues. This is not a normal pin. I used a 1/2 inch pin inside of a 5/8 hole. So therefore there wasn't much clearance and it was relatively safe and it didn't bind at all. First off, my apologies, this video turned out a little bit longer than what I was expecting. If you like this video and you want to see other great videos just like this one, check out my YouTube channel, Shop and Math. If I missed any points, or if you disagree with something that I did, or if you have a suggestion for a new video, please leave them in the comments section below. If you got any value from this video, please like and subscribe. It's free and it'll help me out. All you have to do is click on the icon on my face and I'll do the rest. Thanks for watching the video. Have a great night.